Hello friends, this is our fourth lecture on limit and continuity. In a previous lecture we have seen the neighborhood, limit point, interim point and boundary point. In this lecture we are studying the limit point of a function. That is limit of a function, limit of a function of two variables. ओके टू वेरिएबलचं फंक्शन आहे त्याचं लिमिट चेक करायचं म्हणजे आपल्याला काय घेतलं पाहिजे लेट f be a function of let f be a function of two variable let f be a function of two variable whose domain is d whose domain is d includes arbitrarily close to AB close to point AB close to point AB is close to the point AB then we can say that as we can say that xy approaches to AB then f of xy approaches to L, f of xy approaches to L. We write this as limit as xy tends to AB. Limit as xy tends to AB. That is xy approaches to AB and f of xy approaches to L. That is f of xy is equal to L. Okay. This is the definition of limit in a epsilon delta. That is if that is let f be a function of two variable xy includes a point AB and xy approaches to AB, then f of xy approaches to L. We can write this as limit as xy tends to AB, f of xy is equal to L. If for every epsilon greater than 0, there exists or there is corresponding delta greater than 0. That is for every epsilon greater than 0 there exists delta greater than 0 if xy belongs to D and if xy belongs to D and 0 is less than under root of x minus a bracket square plus y minus b bracket square is less than delta. That is if it satisfies, then the distance between f of xy and L is very small, that is less than epsilon. That is here we have to show that if xy approaches to AB, then f of xy approaches to L. That is if for every epsilon greater than 0 there exists delta greater than 0, say that if the distance between xy and AB is less than delta, then f of xy approaches to L. That is mod of f of xy minus L is less than epsilon. ओके म्हणजे याच्यामध्ये काय सांगितलं बघा फॉर एव्हरी इप्सिलॉन ग्रेटर दॅन म्हणजे f of xy approaches to L लिमिट व्हॅल्यू L ला कधी जाणार तर for if xy belongs to D and 0 is less than under root of x minus a bracket square plus y minus a bracket square is less than delta. It means that the distance between xy and AB is very small, that is a delta. Then mod of f of xy minus l, that is distance between f of xy and l is very small, that is less than epsilon. This is the definition of limit of a function of two variables. Okay. Now this is the limit of a function of a variable. Limit of a function of a three variable. This definition is also same as two variable. Let here be a function of three variable whose domain is B and includes point AB arbitrarily. Then xy tends to AB. For xy tends to AB, we have xyz tends to ABC, we have f of xyz tends to L. That is xyz approaches to ABC, then f of xyz approaches to L. We can write this. We write this sentence and limit as xyz tends to ABC. xyz tends to ABC. F of xyz is equal to f of xyz is equal to L if for every epsilon greater than 0, if for every epsilon greater than 0 there exists delta greater than 0, for every epsilon greater than 0 there exists delta greater than 0 such that if x, y, z belongs to D and under root of x minus a bracket square plus y minus b bracket square plus z minus c bracket square is less than delta, then for x, y, z minus n is less than epsilon. This definition is also same as previous definition of function of two variable. Here we include only the point z. This limit of function says that a point approaches to a, that is point xy in a two variable. We can say that a point xy approaches to point AB, that is the distance between xy and AB is very small, then f of xy approaches to point L. That is, in other words, if the distance between f of xy, and L is very small, arbitrarily, that is very small, the distance between f of xy and L is very small, then the distance between xy and AB, distance between of xy and AB is very small, sufficient. ज्या वेळेला हे अंतर जेवढं कमी घेऊ आपण तेवढंच अंतर इथं सुद्धा कमी होत गेलं पाहिजे किंवा वाढत गेलं. म्हणजे f of xy आणि l मधला डिस्टन्स जर तुम्ही कुठलाही एप्सिलॉन घेतला तर त्यात तुम्हाला एक डेल्टा एक्सिस्ट झाला पाहिजे की ज्या वेळेला xy आणि b चं डिस्टन्स हे डेल्टा पेक्षा काय पाहिजे, मिनिमम पाहिजे, म्हणजे कमी पाहिजे. ओके, आर यू गेटिंग दिस पॉइंट? This is graph. said this is x-axis, this is y-axis, and this is function that is z. Okay, we can take a point xy. We can take point xy, and xy goes to xy. अब उत्तर दान से ह्या पॉइंटचं लिमिट l च्या जवळ असेल. ठीक, मग फिर xy सॉरी ab चं xy ह्या पॉइंटचा एक नेबरहूड आहे. xy ह्या पॉइंटचा एक नेबरहूड काढला. सॉरी ab चा एक नेबरहूड काढला. ab च्या नेबरहूड मध्ये जर xy हा पॉइंट असेल, ab च्या नेबरहूड मध्ये xy हा पॉइंट असेल, तर ह्याची जी इमेज आहे, ती केवढी असावी? l प्लस इप्सिलॉन टू l मायनस इप्सिलॉन ह्याच्या डिस्टन्स वर असावी. म्हणजे हितने येणारी जी इमेज आहे याच्या जवळ इकडं कुठेतरी असावी. म्हणजे द डिस्टन्स बिटवीन l and इप्सिलॉन L and f of xy is very small. The distance between f of xy and L is very small. Then the distance between AB and X is also negligible. That is, delta depends on the only epsilon. If epsilon changes, then delta also changes. Okay. Now, this is graphically seen. Now we see the example. Let's see the example. Using epsilon delta definition. Using epsilon delta definition of limit, show that limit as xy tends to AB x. All students also know this function goes to A. That is, if limit as xy tends to AB, then x is equal to A. Okay, so we have a solution. Here given is a f of xy is equal to x and L is equal to A. Here f of xy is equal to x and L is equal to A. Now we have to show that by definition for every epsilon greater than 0, there exists a number delta greater than 0 such that mod of f of xy minus L is less than epsilon whenever 0 is less than under root of x minus a bracket square plus y minus b bracket square. It's less than delta. And if we have to show that for every epsilon greater than 0, we have to find only the value of delta satisfying this condition. Okay, here f of xy is x. This implies mod x minus a is less than epsilon whenever this is same condition. Okay, now we have to show mod of x minus a is less than epsilon for this delta. We have only to find this delta. Okay, now let's epsilon greater than 0 be any given. Epsilon greater than 0 be any given. We know that mod of x minus a mod of x minus a is less equal under root of x minus a bracket square plus y minus b bracket square. Okay, this value is less equal to this value. Okay, so we can choose. So choose. So we can choose delta is equal to, if we choose delta is equal to epsilon and let this condition that is 0 is less than under root of x minus a bracket square plus y minus b bracket square is less than delta, then consider mod of f of xy minus l is equal to mod of x minus a mod of x minus a. In this we have, from this we have, which is less equal to under root of x minus a bracket square plus y minus b brackets are square. Okay, x minus a, but under root of x minus a bracket square plus y minus b bracket square is also less than delta is equal to epsilon. That is, we have mod of f of x1 minus l is less than epsilon whenever 0 is less than under root of x minus a bracket square plus y minus b bracket square is less than delta. Here we choose delta is equal to epsilon, therefore we have this value. Okay, now I'm again repeat this example. Firstly, we have to show that limit as xy tends to ab, x is equal to a. We have to show this limit by using epsilon delta definition. Therefore, by epsilon delta definition of limit, we have for every epsilon greater than 0, we have to find a delta greater than 0 such that mod of f of xy minus l is less than epsilon whenever 0 is less than under root of x minus a bracket square plus y minus b bracket square is less than delta. Here we have put in the value of f of xy and l. We get this equation. Let epsilon greater than 0 be any element, be any integer, that is, and mod of x minus a. We know that mod of x minus a is always less equal under root of x minus a bracket square plus y minus b bracket square, because mod of x minus a is equal to under root of this positive under root of x minus a bracket square. It's, therefore, if we adding this equation y minus b bracket square, therefore this is greater from this mod of x minus a. Okay, but we know that 0 is less than under root of x minus b bracket square plus y minus b bracket square is less than delta, and if we choose delta is equal to epsilon, now consider mod of f of xy minus a is equal to mod of x minus a, and we know that mod of x minus a is less equal this equation, so we get less equal under root of x minus b bracket square plus y minus b bracket square, but this is less than delta, so we can take which is less than delta, but delta is equal to epsilon, so is equal to epsilon, therefore we have mod of f of xy minus l is less than epsilon. This is the complete solution of this question. Therefore we get limit as xy tends to ab, xy tends to ab, x is equal to a. Okay, now we can take the next example. Similarly, next example is limit as xy tends to ab, limit as xy tends to ab, y is equal to. This is similar question solution. Here f of xy is equal to y and L is equal to L is equal to B. And if we have to find, that is, we have to show that for every epsilon greater than 0, there exists delta greater than 0, such that for every epsilon greater than 0, there exists delta greater than 0, such that mod of f of xy minus L is less than epsilon whenever 0 is less than under root of x minus a bracket square plus y minus b bracket square is less than delta. That is, we have to find only this delta depends on this epsilon. That is, for every epsilon greater than 0, there exists delta greater than 0 satisfying this condition. Here, f of xy is y, so this implies mod of y minus b is less than epsilon whenever this is a sentence. Okay. That is, if epsilon greater than 0 be given. Okay. Now we know that mod of y minus b, we know that mod of y minus b is also less equal under root of x minus a bracket square plus y minus b bracket square, which is also less than, sorry, if we choose so we also know that this is less than delta, so we can choose delta is equal to epsilon, then and 0 is less equal under root of x minus a bracket square plus y minus b bracket square is less than delta. Then we can consider the sentence mod of, consider the equation mod of f of xy minus f, mod of f of xy minus l, and we have to show that mod of f of xy minus l is less than epsilon. Whenever that is, this is a given condition, we can take, then we have to show that this is less than epsilon. So mod of f of xy minus l, putting this value of f of xy is equal to y minus b, but we know that mod of y minus b is a less equal under root of x minus a bracket square plus y minus b bracket square. But we know that this under root of x minus b bracket square plus y minus b bracket square is a less than epsilon, therefore, sorry, is less than delta, and if we choose delta is equal to epsilon, so we have is equal to epsilon. Therefore, mod of f of xy minus l is equal to, sorry, is less than epsilon. Therefore, by definition of epsilon delta, we have limit as xy tends to ab, y is equal to limit as xy tends to ab, y is equal to b. Here we can solve this example same as previous example. Here f of xy is equal to y and L is equal to b. We have to show that for every epsilon greater than 0, there exists delta greater than 0, such that mod of f of xy minus L is less than epsilon whenever 0 is less than under root of x minus b bracket square plus y minus b bracket square is less than delta. This implies mod of y minus b is less than epsilon if epsilon greater than 0 be any given element, epsilon greater than 0 be any given number, then we have to find delta. Such that this satisfying this condition. So for given epsilon greater than 0 is given, and we know that mod of y minus b is also less equal under root of x minus b bracket square plus y minus b bracket square. But this value is less than delta, so we can choose this value. Sorry, we can choose delta is equal to epsilon and 0 is less than under root of x minus b bracket square plus y minus b bracket square is less than delta. Now we consider mod of y minus b is, that is mod of f of xy minus L is equal to mod of y minus b, but mod of y minus b is less equal under root of x minus b bracket square plus y minus b bracket square, but this, by this condition, this is less than delta. So this is less than delta, but delta is equal to epsilon. Therefore we have mod of f of xy minus L is less than epsilon. That is the definition of limit. Therefore by definition of limit of xy tends to infinity, y is equal to b. Okay. Now we see the next example. Ready? Here we see that here f of x1 is equal to c, f of x1 is equal to c, and here is also c. Okay. Also we have to show that we have to show that for every epsilon greater than 0 there exists delta greater than 0 such that mod of f of xy minus L is less than epsilon whenever 0 is less than under root of x minus a bracket square plus y minus b bracket square is less than delta. But here mod of f of xy minus L is equal to, here mod of f of x is c and here is also c is equal to 0 is always less than epsilon. Therefore for every delta greater than 0, this condition is satisfied. Therefore, we have for every epsilon greater than 0, there exists delta greater than 0. But in this example, for every delta greater than 0, this condition is satisfied. Therefore, we have limit as xy tends to AB constant is equal to constant. Okay. Thank you for watching this video. Thank you very much.